Hello there, friends and neighbors. I'm going to show you now how to write a complete example of a results section for a single quantitative variable. So this is going to involve a single sample t-test and a confidence interval for one population mean. Okay, so the data set that I'm going to be using is called the team called Diesel Guys. And what they did was they went around and sampled randomly 30 members of the Diesel Tech program and asked them how many times do you fill your tank in 2 weeks? And their null hypothesis was that it was exactly 2. Okay, so here's a complete results section. Every results section has these pieces in this introductory stats class. They all have this, and this is typical of even a more these are typical components that go into even a more professional research paper. So really we need 3 main components in the results section. Well, the heading, results. And the 3 main components are going to be the descriptive statistics, a graph, which is sort of an extension of the descriptive statistics. It characterizes your sample. And then finally, the inferential statistics. Now the inferential statistics need to first have your statement of your null hypothesis, your alternative hypothesis, and alpha. Then we need to see the check of assumptions. Then comes the actual fun part, the confidence interval, if appropriate. Hypothesis, well, your test statistic, degrees of freedom, if appropriate, and a p-value. Okay, that's typical. Certainly, that's for anything in the introductory stats class that's required. And then, let's see. Then we have decision about HO. And along with this, we want the interpretation of the confidence interval, if there is one. And then lastly, would come the, put it into plain English, so. For the research context. And this is where you explain to the reader, me, that you know what this actually means and what you actually discovered. Okay. Got your null hypothesis, check of assumptions. If you don't meet the assumptions, you really should stop doing the research. But for purposes of an introductory class or a research project for a class, you might sometimes just acknowledge you fail the assumptions and then move on. Okay. So let's create our first example of this. I've got the data set already imported, and that's something you're going to need to do is use R, and I'm using R Commander and EasyR. All right, so first the descriptive stats. Statistical analysis, continuous variables, numerical summaries. This is how you get the mean and standard deviation. Gas fill-ups. And the default is perfectly correct. You just click OK, and there it is. The mean is 2.4. The standard deviation is 1.4. So you would say x bar, the sample mean, equals 2.4. The sample standard deviation equals 1.4. And the sample size is 30. Okay, that's it. Now for the graph, there are many types of graphs that would be appropriate. A box plot would be appropriate. A histogram would be appropriate for a single quantitative variable. Let's just make let's make a histogram. That sounds like fun. So you go graphs and tables, histogram. Choose the variable, which is gas fill-ups, and then click OK. And there it is. Okay. And what I'm going to do is screenshot that. Copy it to clipboard, clip it, and then paste it into my Word document. Now, if you're using for most software applications, if you're using Windows or Mac, you can actually just right-click on the image and copy it and paste it. I'm doing something a little different because of the software that I'm using at home. Okay, make it smaller so that it's more reasonable to look at. Cut it, and then boom, there's a graph. Okay, I'm going to anchor it as character. Okay. Taking too long. All right, so now we get our inferential statistics. Now, this particular team, they can choose anything they want for their HO. Null hypothesis is always of the form parameter equals number. That's what it always is. Can I get this out of the way? Quit. All right. Anyway, so it's always of the form parameter equals number against H1 parameter does not equal number. In our case, and then you choose alpha, which is typically going to just be 0.05. So that's what you have there. Now, our parameter is mu. The population mean is what you're estimating. And we're going to hypothesize that it's twice a week on average that people fill up their tank. Check of assumptions. Well, we always assume independence. In addition to independence, we assume that for a single quantitative variable for estimating mu, either the variable is normal or n is large. Large can be at least 30. Now, if we look at this histogram, you can see that that variable is not normal. That's okay, though, because their sample size is 30. N equals 30, so we meet the assumptions. That's fine, and that's that. Next, we're going to go do the actual computations. So go to R again. Statistical analysis, continuous variables. Always, if you've got a quantitative variable, you go to continuous. Then you go to single sample t-test, gas fill up. Mu equals, we're going to make it two-tail alternative, and set the null hypothesized parameter value to 2. Then you click OK. And there you get it. Here's your t, degrees of freedom, and p-value. I'm going to copy that, paste it. I'm going to get the confidence interval as well. And here it is, 1.9 to 2.9. Okay, now we're going to interpret this. We are 95% confident that in the population, diesel tech students fill their tank between 1.9 and 2.9 times per week. Okay. 1.9 and 2.9 times per week. Can't see it. Okay. Let's see. The p-value is greater than alpha. We fail to reject HO. Okay. Now finally, we put this into plain garden variety English. It is reasonable to conclude that the average number of fills per week is 2. It's not going to be rejecting that hypothesis. So that's a complete results section from beginning to end. You've got your descriptive statistics, your graph, and your inferential statistics, which include your statement of HO, H1, alpha, assumption check, test statistic, degrees of freedom, p-value, confidence interval, decision about HO, and interpretation of the confidence interval, and then finally put it all into plain English. And that's a results section for a single quantitative variable.